Hello, everyone. My name is Dr. Nathan Pelletier. I'm an assistant professor at the University of British Columbia. I currently hold the NSERC Egg Farmers of Canada Industrial Research Chair in Sustainability, which is a subject of my presentation today. Specifically, my aim is to provide a high-level overview of the kind of sustainability measurement and management work that my lab is doing to support Canadian egg farmers. I'm going to begin by speaking briefly to how we approach sustainability measurement and management. I'll next talk about some of the key ingredients that we need to do it well with examples from my lab. And I'll conclude with a shameless pitch for collaboration, because in this inherently interdisciplinary research space, success ultimately comes from connecting the dots. Now, everyone has a pretty good idea about what sustainability means, but measuring and managing for sustainability in agriculture is actually far from a straightforward exercise. This is because modern agricultural activities are embedded in interconnected industrial supply chains. These supply chains are supported by flows of material and energy resources with associated emissions, and that can impact on the environment in different ways, in different places, and to different extents. This means that to be effective, we really need to be thinking and acting at a systems level. For this reason, a concept called life cycle thinking has emerged as the central paradigm of sustainability science. Take egg production, for example. For most of us, when we pick up a dozen eggs from the grocery store shelf, we are largely oblivious to the story behind what we are buying. Of course, we know that the eggs were laid by chickens on a farm and subsequently transported to the grocery store. But that singular act of a chicken laying an egg is itself predicated on a broad and complicated network of relationships. This network spans activities from extracting the fossil energy resources that are used to produce the fertilizers and to power farm machinery in order to grow and to process the crops that are ultimately fed to laying hens. It also includes breeder farms, hatcheries, pullet facilities, and layer barns. On egg farms, laying hens may be raised in a variety of housing systems. Each system, indeed each farm, will be characterized by differing resource efficiencies and impact profiles. The egg industry also relies upon a network of transportation, grading, processing, and packaging systems. So managing egg production for sustainability absolutely requires that we be attentive to all of these relationships. It requires that we seek to understand which of them really matter for specific sustainability objectives, and that we seek to influence them accordingly. This is a pretty tall order. Fortunately, in practice, life cycle thinking is operationalized through rigorous standardized methods like environmental life cycle assessment, which provides a framework for systematically quantifying how those activities along each stage of the supply chain contribute to a range of potential environmental impacts. The overarching goal of the NSERC Egg Farmers of Canada Industrial Research Chair is to advance the science and the practice of sustainability measurement and management in the Canadian egg industry based on life cycle thinking and assessment. Towards this end, my lab at UBC is engaged in a 5-year program of research to advance sustainability outcomes in the industry. Our research program has 3 core themes, respectively focused on data, models, and decision support tools. I'll briefly describe each of these in turn. Let's start with data. As you can imagine, measuring and managing for sustainability across the supply chain requires a lot of high-quality data. This has often presented a real stumbling block to agricultural sustainability research in Canada. The first of our 3 research themes is therefore focused on building and populating a publicly available repository of high-quality data sets for characterizing agricultural supply chain activities. This repository, which is called the Canadian Agri-Food Lifecycle Data Center, has been online and operational since early 2020. In collaboration with the National Research Council, it is currently being scaled up to create a national cross-sectoral life cycle inventory database. Our second research theme is focused on comparing the potential efficacy of different technologies and management strategies that could be adopted by Canadian egg farmers or by their supply chain partners in order to increase the sustainability of egg production. I've made a list here of just a couple of the projects that have been completed to date or are nearing completion, and I will elaborate on some illustrative examples. As a first example, it's widely recognized that nitrogen is a critical part of the sustainability equation in agriculture. Indeed, work that I've previously published has pointed towards the important role of nitrogen in the life cycle environmental footprint of egg production, as well as the need for nitrogen use efficiency management across the supply chain. I hence tasked one of my master's students, Shiva Zargar, with identifying and comparing available nitrogen use efficiency technologies and management strategies using life cycle assessment. Shiva identified 5 critical intervention points and priority technologies for consideration, and then developed detailed supply chain models to determine their relative efficacy in improving nitrogen use efficiency, as well as the overall environmental impacts of egg production. Without getting too far into the weeds here, Shiva found that while each approach could certainly improve nitrogen use efficiencies, this often came at the expense of increasing environmental impacts for other indicators, such as energy use or greenhouse gas emissions. Her work underscored why it really is essential to employ life cycle thinking and assessment when undertaking to, for example, formulate feeds for reduced nitrogen excretion. If reduced excretion in a layer barn is offset by higher supply chain nitrogen losses due to producing specific substituted feed crop ingredients, we may not actually achieve our intended objectives at a systems level. Her work also highlighted the importance of implementing renewable energy systems in agriculture, since many technology options for nitrogen use efficiency require industrial energy inputs, which can otherwise offset the gains associated with those nitrogen use efficiency measures. There are, of course, a variety of interesting options for integrating renewable energy systems and generally improving energy efficiencies in the egg industry. One such option is the use of net zero energy buildings, which are defined as highly efficient building systems with integrated renewable energy generation capacity that can offset any non-renewable energy consumption. Indeed, many of you will have heard of the Brant Colony Net Zero Energy Layer Barn Pilot Project, which is located in southern Alberta. This project aims to trial net zero energy technologies for the egg industry. My student, Yang Li, developed detailed life cycle assessment models of the Brant Colony system in order to evaluate its efficacy and to inform design considerations for future net zero energy barns in Canada. Yang found that although the life cycle impacts of the infrastructure systems are higher for the net zero energy barn compared to a conventional barn, these are more than offset by reductions in the direct energy inputs that are required to operate them. For example, the life cycle carbon footprint per ton of eggs produced is roughly 12% lower in the net zero energy barn, while cumulative energy use is 29% lower. However, these results are specific to Alberta, where the renewable energy system is offsetting grid electricity that is largely produced from fossil fuel sources. By calculating environmental impact payback time, which is the time that it takes for the environmental benefits generated by a technology system to offset the impacts associated with the production of that system, Yang also demonstrated that payback would be much longer in provinces with green energy grids. It may not be achieved within the lifespan of the barn for some impacts in some provinces. Again, these results underscore the fundamental importance of life cycle thinking and assessment in sustainability measurement and management. Now, thus far, all of what I've described is largely traditional academic research. But for an industrial research chair, where the rubber really hits the road, is in the translation and transfer of this research into accessible and effective decision support for egg farmers. So our third research theme has focused on exactly that. The National Environmental Sustainability Tool is the capstone project of our 5-year program of research. What NEST aims to do is to put all of the data and the information that we've generated directly into the hands of egg farmers in the form of an online farm-level sustainability assessment tool. This platform will enable farmers to measure their life cycle environmental impacts, compare their farm results against regional and national benchmarks, and assess the mitigation potential of adopting context-appropriate green technology systems and management strategies. So, I hope that this has given you a taste of the why, the what, and the how of the NSERC Egg Farmers of Canada Industrial Research Chair in Sustainability. Several of my students are also slated to present during this forum, so do tune in if you'd like to learn more. Now I promise to conclude with a shameless pitch, so here it is. As evidenced in this forum, there is a lot of fantastic research happening across the poultry industry, undertaken by researchers with highly specialized expertise in their respective domains. A lot of this work will intersect with sustainability considerations. So if you see an opportunity or a need or have a desire to engage with us on a collaborative project to research the sustainability implications of a technology or a management strategy for the egg industry, drop me a line. I would be very keen to hear from you. Thank you.
Thank you very much for a great way to start the day, and I'll definitely take on your your call, because I think it is a great idea to move directly to an application on farm. So thank you very much again for that. We do have a questions here in the question and answer box, and I'll read it to you from Daniel. Poultry and egg farmers have access to a government investment fund. What, in your opinion, would be the best investment for layer producers to make to improve the sustainability efficacy of their operations? What change or implementation would give them the most bang for their buck?
That's a wonderful question, and it is very topical in light of what I was endeavoring to stress in my pre-recorded talk about how important it is to apply life cycle thinking and really look at a farm in its particular context. Now we have a good idea, at a high level, what are the major drivers of impacts in producing eggs from a life cycle perspective. And these are things like, feed use efficiency and manure management. Those kind of big ticket items are common across egg farms. But what technologies really will make sense for a particular farm will depend on where that farm is located, right? So a technology that makes sense, say in Ontario, may not make sense for a farm in Alberta and vice versa. So we really have to think, for example, if we're going to implement some new renewable energy system, what are the available resources in that area, right? In some areas, we have good solar resources, and some areas, mid or low availability of solar resources, or similarly for wind resources. Or if there is interest around, valorizing a waste stream, it may not make sense to have, an individual farm level manure valorization system, say a biodigester. But if there's sufficient farm density in a region, then a regional hub for that kind of activity might make sense. So we really need to look at the context in which the farm is situated, and then assess the mitigation potential of the different options for that farm, which is precisely what the NEST tool that you'll hear about a little bit later in this session is designed to support.
All right, thank you very much. Yeah, I'm looking forward to see more details on the NEST tool. I find that quite interesting. Just a little quick questions here before we wrap it up to the next speaker. Initially, on your data part, you rely on receiving data, I believe, from third party. How is it to get reliable data from private third party?
It is a challenge, but it's a challenge that in this field of research you necessarily need to embrace. One of the students in this session that you will hear from, he actually spent 3 months driving coast to coast across this country, sitting down with egg farmers at their kitchen tables, in diners, to fill out a long survey to collect data. And he ended up collecting a really high quality data set representing more than 200 farms Canada-wide. So it really takes that level of engagement to derive high quality research. But again, with the NEST tool that we're developing, where farmers are willing, we are going to ask them to contribute their data to keeping our data set updated in an aggregated, confidential manner.
All right, thank you very much.